Alright, this is Ken Rosever. We're going to talk about expectation. Variance we're going to save for another video. Expectation is a quantitative measure of what you expect given a certain probability distribution. When you have a probability distribution, it says you have a certain probability of this happening, you have another probability of this happening, you have a probability of that happening, and something else happening has another probability. But if you performed this experiment or you did this thing a million times, the expectation would be the average outcome of all those possible outcomes put together. Okay, so it's a very useful tool. It basically amounts to the average, or the weighted average, if you think of the probabilities giving each different outcomes value a specific weight. And we'll look at it in the context of bond investment and then some other examples so you can get an idea of how it's used and what is it good for. So bond investment, this is from page 273 in your book. It says a financial advisor suggests that his client selects one of two types of bonds. Bonds are issued by companies and cities that are trying to raise money. So what they do is they create bonds which are basically official IOUs, and you can buy them, and they have a term, and they have they pay a certain percent per year. But you know, sometimes they default on the bonds, and that's what we're looking at here. Alright, so the financial advisor suggests that his client selects one of two types of IOUs in which to invest $5,000. Bond X pays a return of 4% and has a default rate of 2%. And that would be based on past bond issues. They would go, oh, the return in the past has been 4%, but they've defaulted 2% of the time. Okay, Bond Y has a 2.5% return rate and a default rate of 1%. So what they want us to do is find the expected rate of return and decide which bond would be a better investment. And you need to note here that when a bond defaults, the investor loses all of the investment. Okay, so what's a rate of return? A rate of return is what you get on top of your investment back at the end of the term. So for Bond X, the rate of return is 4%. So if we go and try to calculate 4% of 5,000, we multiply and we get $200. And that's for Bond X. So now if we want to figure out the expected value, though, we have to start putting in the probabilities. We know that the formula for expected value is the average, or E of X, expected value of X, and it's equal to the sum of the values times the probability for each value. So the first value we see is the $200, and we expect to make that $200. Let's see, what's the default rate? 2% of the time it's default, so we expect to make $200 98% of the time. The other 2% of the time we expect to lose $5,000, which is unfortunate, but it happens. And if we add these things up, this is 196, this is negative 100. The expected value is $96 for Bond X. Now let's do Bond Y. Bond Y pays 2.5%, and it's still on a $5,000 investment, and so that is $125. And when we do the same formula, which is the sum of the x's times the probability of each x, the sum of the values times the probability of that value happening, we get, let's see, we expect to make $125. What percent of the time? Well, the default rate, as we can see right here, is 1%. So we expect to make $125 99% of the time. So that's a good thing. It has a lower default rate than Bond X. But we expect to lose $5,000 1% of the time. So doing the calculations on this, and you would have to use a calculator. I'm just going to look it up in the book. Let's see what they had. 73.75 was their answer. And you would get that by multiplying those and subtracting. Okay. Or adding if you get a negative over here, whatever. Anyway, so this one came out 73.75 and this one came out 96. So in the long run, if you continually invested a number of times in each of these bonds, this one would come out on top in the long run. Okay, so the expected value here is higher than the expected value on bond Y. So that would be your answer. We'll do another one if we have time. Let's see. No, I'll just cut this video here and I'll do the next one on another video. So that's it. Bye-bye.